Hello, this is a short lesson that revolves around working with lab number 5. And lab number 5 is primarily using subroutines. And subroutines are kind of their own program, but it's a program that's called from some other program, mostly the main program. So you can see here over on the right-hand side panel, I have a main program. Okay, and I have a subroutine. The subroutine happens to be called modifier 1. And this program, the main, will call the subroutine program and execute part of its code. Now to do that, we require the use of a JSR instruction, and this is the JSR. The JSR instruction also requires that you identify the program that you're going to call or execute from the main program. In this case, it's called modifier 1. So again, this is the subroutine program. And in the subroutine program, two important parts of your program are the subroutine instruction. Okay, the subroutine must have a subroutine instruction, and it must have a return instruction. And this is the return down here. As well, on this first line of the subroutine instruction, it must have an output energize. Doesn't really matter what you call it, and it doesn't really get used unless you want to, but it needs to be there. If it's not, you will get a syntax error. Okay, so you must have the subroutine, you must have the return, and in between is what gets executed. And what will happen is the main program will call the subroutine with the JSR. It will go off to the subroutine, execute all of the code, and then return back to the main program. Okay, and as I said, one of the reasons for using subroutines is that you may want to use the same code repeatedly in your program and call it more than one time. It can be easy to modify a subroutine, and it's very easy to organize your program in various subroutines. Now, while we're on this screen here, something I want you to notice is that I am in run mode. All three of these lights are turned on. This is green, okay? And you can see the bars on the left and the right of the ladder logic are also green. So this program is executing. Over on the left, we have the HMI, okay? And you can see what's happening. Let's go back to the main program because that's what's executing right now. This will not execute until I press that mod A push button. So all it's doing is executing this oscillator where it's oscillating between this top timer, you can see it changing, bottom timer, top timer, and it happens automatically. And all we have here are two timer timing instructions. One is checking the off timer, one's checking the on timer, but just going back and forth. And then on this second rung, what I have done here is whenever the pulse width modulation A on timer is enabled, it turns on bit 6 of the port. And the port is out here. So I've created a tag called port, and it represents these 7 or 8 bits. There's actually 8 bits. You don't see the 8th, but there's 8. And these represent each bit of that port. So port dot 0, 1, 2, 3, 4, 5, which is not visible, 6, and 7. So I'm controlling bit number 6, and you can see that over here. And my oscillator is currently 1500 milliseconds of on time and 700 milliseconds of off time. And if you look carefully, you see that here. 1500 on, 700 off. And it appears over here. It's telling me what my on time is and what my off time is. So the whole idea behind this program is to be able to change the on and the off time of the bit 6 light. Okay, that's my pulse width modulation. And pulse width modulation is sometimes used to control the amount of power going to a heater, to a light. So the more on time you have, the more power is getting to that light. But we want to be able to control what's called the duty cycle, the amount of on time versus the period. And we can do that with this subroutine. So let's kind of analyze what happens here. So in my main program, I have parameters. Okay, and you can see here that there are 4 parameters. These parameters allow you to pass information from the main program to the subroutine, back and forth, and from the subroutine back to the main program. So you'll see that there are two terms there, one called input parameter and the other is called return parameter. And the parameters that I'm moving are the on and the off time presets. Okay, notice it says .preset. So I'm reading that variable and I'm going to send it to the subroutine. The subroutine is going to modify it and return it back here. And when this returns, it also modifies these values. Okay, it goes back and forth. So let's have a look at what happens here. So I'm going to set this switch because my subroutine is going to make use of this switch, okay, the increment and decrement. When it's in the up position, the bit is equal to a 0. When it's in the right position, it's equal to a 1. So you could say that it's closed for increment and open for decrement. And this is a normally open push button. So notice here the current values of the on and the off time, 1500 and 700. So I'm going to decrement the on time. That's what that subroutine is going to do. So let's have a look at what happens when I press that button. It goes down, goes down, goes down, goes down. And if I change the button to the increment position, it increases by 100 milliseconds at a time. So what happened is the current values of on and off were passed to the subroutine, and then they get returned back from the subroutine. So let's look at what the subroutine does. Okay, so here's our subroutine. So basically the input parameters are stored to these two variables in order. So the first parameter goes to time on, second to time off. And then in the return parameters, it returns the modified on time and the modified off time back to the main program. All right. So, and notice that if the switch is closed, I'm incrementing, which it's in right now. I'm doing an add instruction, adding 100. And if I move this switch to the decrement position, you'll notice that this line is being executed. Well, only when I press the button, only when I press modify A, but this line will be executed. Okay. Now the next thing that happens in this case here is that, let's say I'm going to set it up for incrementing. Every time I execute this instruction, it'll add a value to the time on. In this case, it's 1500. It's going to take that value, divide it by 100. Okay, so it's going to take 1500, divide it by 100, and that gives me 15. And I want to display that 15 to the screen. And I want to display it just to the lower 4 bits of port. So that's what this instruction is doing. This move mask is a very unique instruction and allows the output, in this case port, to modify or to be modified, but only modify the lower 4 bits. And that's why I've selected ones in the mask. So the ones pass the data through, the zeros block the output from being changed. And that's important in this case because we don't want these 4 outputs, well there's 4 but we only see 3. We don't want them to change because they're being used for something else. Okay, but now if I change this to decrement and I press this button, okay, you can see the timer value going down. So it's 1200, 11, 1000, and we'll go all the way down to 100. I won't go past that. There are going to be some other things to prevent that from happening. So here we're at the timer is equal to 100. 100 divided by 100 is 1. And that's what you see in this bit pattern. It's taking that factor, sending it to the port, and that's why the last 4 bits of the port are a 1. So this has a weighting of 1, 2, 4, and 8. So let's say I press that mod A again. Oh, we're going the wrong way. So we want to go up. We want to increment. So that's a 1, a 2, 3, 4, 5, because this is a weighting of 1 and 4. This is 6, 2, and 4. 7. 1 plus 2 plus 4 is 7. That has a weighting of 8. 8 plus 1 is 9. 8 plus 2 is 10. It's 11, 12, 13, 14, 15. And that's the maximum we can go to. 1, the minimum, and 15, the maximum. So I'd want to decrement now. Okay. Now, the other thing to notice here is that if you had an error in your program, this is something a lot of students don't realize, but you would click on this Verify Routine button. Very, very useful. It tells you where there is an error in your code. Hello, I wanted to show you an example of a subroutine and main program combination. So this is fairly simplified, what I've done here. It's a program like we'll be using in lab number 5, but definitely not the same. So in the orange box is the main program. On the right-hand side is the subroutine. And the the main program has a JSR, jump to subroutine instruction. The subroutine program will have an SBR, or subroutine instruction. And this program also has an output instruction. It must have it. If not, it will have an error. And here we're making a change to a value that we've stored in memory. We have a value called total, and we're going to increase the value of total. I called it total within here, so slightly different than the variable over here. In the main program, the variable is called count. In the subroutine, the variable is called total. And it's a good practice to use different names within the main and the subroutine. And so when we talk about subroutines, we're talking about programs that call the subroutine. That's a good description of what we're doing. We're going to that subroutine. And once we're in the main program, once we're in the subroutine, we're going back to the main program. So let's look at what happens here. So I have this variable called count, and it's initially equal to, in this case, 33. Okay, before any execution happens, it's equal to 33. I have a push button instruction. Okay, this is my push button over here. And when we press that button, it's going to cause the one-shot to produce just a very short pulse that will execute this JSR only one time. And the JSR has two parameters, an input parameter and an output parameter. Input parameters are what are sent to the subroutine. Return parameters are values that are returned back from the subroutine to the main program. So in this case, my count starts off at 33. So that value appears in my input parameter. It's a variable stored in memory. When I execute the subroutine, it automatically moves the value in the input parameter to the input parameter of the subroutine. That happens automatically. Okay. And then within my subroutine, I'm modifying that variable, in this case called total, by adding 1 to it using a compute instruction. So my total is now, in this case, 34. And 34 is stored in the return parameter area so that when my subroutine is completed, it automatically moves that 34 back to the return parameter of the subroutine. And now in my main program, the new value that's returned is 34. And what will happen if I press that modify push button again? Well, this will now be 34. 34 gets moved into here. 1 is added to it, making it 35. 35 gets returned back to here. And after the execution, this is now 35. And it gets repeated over and over again. Hello, I wanted to show you an example of a subroutine and main program combination. So this is fairly simplified, what I've done here. It's a program like we'll be using in lab number 5, but definitely not the same. So in the orange box is the main program. On the right hand side is the subroutine. And the subroutine, the main program has a JSR, jump to subroutine instruction. The subroutine program will have an SBR, or subroutine instruction. And this program also has an output instruction. It must have it. If not, it will have an error. And here we're making a change to a value that we've stored in memory. We have a value called total, and we're going to increase the value of total. I called it total within here, so slightly different than the variable over here. In the main program, the variable is called count. In the subroutine, the variable is called total. And it's a good practice to use different names within the main and the subroutine. And so when we talk about subroutines, we're talking about programs that call the subroutine. That's a good description of what we're doing. We're going to that subroutine. And once we're in the main program, once we're in the subroutine, we're going back to the main program. So let's look at what happens here. So I have this variable called count, and it's initially equal to, in this case, 33. Okay, before any execution happens, it's equal to 33. I have a push button instruction. Okay, this is my push button over here. And when we press that button, it's going to cause the one shot to produce just a very short pulse that will execute this JSR only one time. And the JSR has two parameters, an input parameter and an output parameter. Input parameters are what are sent to the subroutine. Return parameters are values that are returned back from the subroutine to the main program. So in this case, my count starts off at 33. So that value appears in my input parameter. It's a variable stored in memory. When I execute the subroutine, it automatically moves the value in the input parameter to the input parameter of the subroutine. That happens automatically. Okay. And then within my subroutine, I'm modifying that variable, in this case called total, by adding 1 to it using a compute instruction. So my total is now, in this case, 34. And 34 is stored in the return parameter area so that when my subroutine is completed, it automatically moves that 34 back to the return parameter of the subroutine. And now in my main program, the new value that's returned is 34. And what will happen if I press that modify push button again? Well, this will now be 34. 34 gets moved into here. 1 is added to it, making it 35. 35 gets returned back to here. And after the execution, this is now 35. And it gets repeated over and over again. All right, this is part 2 of the demo. And here I've added a little bit more code to the program. I now have a line of code that's going to restart my preset for the on time to be 700 milliseconds. So when I press, and let's download this, you can see that it's not running right now, so I'm going to download it. And we have to go into download mode. There we go. Okay, now that it's downloaded, you can see that the program is running. Okay, and it has the on time and the off time equal to 700 milliseconds, but my switch is set to increment. So if I press this button, well, I will increment. And it went to 800, and it modified the factor so that it equals 8 for 800 divided by 100. In this case, not the same as the program you will write. and then I increment it again, it goes to 900, and 1000 divided by 100 is 10, so that represents a 10, 8, and 2, and so on. And you can see the program changing here as well. The other thing that's very valuable when you're troubleshooting the program is you can hover over the variables. So you can see that the on time is 1200, the off time is 700, and since these tags are exactly the same, they will have the same value. The only thing that happens is that these two tags send information to the subroutine. These two tags receive the information from the subroutine. And let's just go to that subroutine. One of the things I've done here is to make sure I don't go over certain values. I can use less than and greater than instructions. Okay, in this case I'm just going no less than 100 and no more than 1500. That way when if I keep hitting while I'm decrementing, keeps going down, sorry, I'm incrementing right now, so it's going to the maximum of 1500, and it can't go beyond that point. Okay, it won't go beyond that point. And if I click decrement, it'll only keep decrementing as long as I'm not less than 100. It has to be greater than 100. Well, here I'm not greater than 100, so none of this code gets executed. And on the right hand side, it's computing the factor using a compute instruction, and then it's sending the factor information to the lights using a move mask to the ports. Okay. Now if I want to be able to see the ports in hexadecimal, one of the things that you can do, and I might have to go offline for that, but I'll try without going offline. You can edit the port properties and select the style in which you want to view the data in hexadecimal. And yes, you can see that it updated it. So you have a 1 here. Let's increment so we can see those numbers change. Okay, so it's 2, 3, 4. Now you might wonder, why is that other number flashing between 1 and 5? And that number is reading the upper 4 bits. And this one's always a 1, and this one sometimes is on, sometimes it's off. But if you add them together, that's 1, 5, 1, 5 on the upper 4 bits of that hex number. So that's why it's flashing on and off. Now the last thing I want to show you is the program. So here you can see in the program that I have a main program. These are where my tags are located, so I can look at my tags. I'll just move this window over so you can see them. And there's two ways to look at the tags. You can look at them in edit mode or in monitor mode. So monitor mode allows you to look at and change the values of the tag, and edit mode allows you to add, delete, or change tags. So most of the time I want to be in edit tags, or sorry, in monitor. I have to move over here, I think. There we go. So I'm in monitor mode there. And notice here that there's a little number 1 beside this first ladder logic program, which is my main program. Okay, I can click on it, and this is my subroutine. And right now I can maybe move this over to see the entire subroutine. Whenever it can't fit onto one line, it scrolls down to the next line. I might be able to make it bigger. No, that's the least I can go to, but I can move this over. Still not enough. Okay, we won't worry about that. But that's the subroutine. Sorry, this is the subroutine, this is the main program. When you want to add a subroutine, you click on main program, right click, then add, and this is where you'd add your new routine, and you have a choice of ladder, sequential function charts, structured text, or block diagram. We're today working with just ladder logic. So I hope all of this helps, and the HMI also shows you the value of pulse width modulation B. So you actually have to create a second pulse width modulator. You have to change all the code within your main routine. Okay, I'm not giving you all the code. There's actually more lines of code. This is just to get you started. But I hope that helps. Thank you. Bye for now.